Hello Internet and welcome to this quick video on specific heat capacity, perfect for GCSE Science. Now, we can start off by saying that specific heat capacity is the amount of energy required to raise the temperature of 1 kilogram of any substance by 1 degree Celsius. And from here, we can create an equation. And the equation for specific heat capacity is that a change in thermal energy measured in joules equals the mass measured in kilograms times specific heat capacity, which is measured in joules per kilogram per degree Celsius, times temperature change, which is obviously in degrees Celsius. And this will generally be simplified down to this is the same thing, but just written in a smaller version. The small triangle you see there, that is the Greek letter delta, and it just means change in. So therefore, we have change in energy equals mass times specific heat capacity times change in temperature. And now let's take a look at a couple of examples of questions. So you can pause the video now if you'd like to give this question a go by yourself. Otherwise, just follow along with me. So the question is telling us that water has a specific heat capacity of 4,180 joules per kilogram per degree Celsius. How much energy would it take to heat the 5 kilograms of water by 1 degree Celsius? All we have to do here is plug our numbers into this equation, so we can say that the change in energy, because we're looking for the energy we need, so we don't have to rearrange the equation at all, is going to be 5, as we've got 5 kilograms with mass, times our specific heat capacity of 4180, times that 1 degree, and putting this in a calculator, we get an answer of 20,900 joules. Really simple. Our next question is a little more difficult, as it requires us to rearrange the equation somewhat. So we are told that 1,495 joules of energy are required to raise a 325 gram substance by 11 degrees Celsius. Work out the specific heat capacity. So the first thing we want to do is just plug our numbers into the equation we already have. And you'll notice that I have left 325 grams as 0.325 kilograms, as mass is always going to be in kilograms in this equation. And C is our specific heat capacity. I've just left that as C from our algebraic equation there at the bottom. Now, rearranging this, we first need to divide both sides by 11, as the side where the C is on is timesing by 11. Therefore, to get rid of it, we have to divide by 11, and whichever we do to one side, we must do to the other to keep it a fair equation. Therefore, we're going to end up with 1,495 over 11 equals 0.325 times C, and then simply from here we're going to divide both sides by 0.325. So now we have 1495 over 11 times 0.325, because when you're dividing over to a side that already has a denominator on its side, you can just simply times by that denominator and you'll still be dividing through, and this equals C, and then we put this in a calculator to get an answer of 418.19 joules per kilogram per degree Celsius.